All right, guys. So we are doing lesson 88 today, February 20th. The answers to tonight's homework is already on the blog. Please go to the blog tonight, check your answers, and then just leave your initials. Say, hey, I was here, initials, or first name, last initial, whatever your parents let you do. However much anonymity you need. Just let me know you were there. And please, as I said, don't go on there if you weren't, because you're fooling me and you win, but it doesn't really do anybody any good. So if you don't go on there, just don't say you did. If you went on there, please, drop your name in there so I know you did. But I'm not looking to see who's on there and who's not so I can be mad at you or affect your grade. It has no bearing on your grade. I'm just trying to get an idea if it's being used and by who. Okay, so there was a question about yesterday's lesson before we get into today's lesson. Do you have a specific example, Emma? Huh? Everyone has a problem with it? With Okay. Give me an example. Okay, in parentheses, negative 3xy squared in parentheses, like that. It's just y. There's nothing by x. Listen, it would be both, guys. Watch. It would be both if I had the 2 out here, right? Then it's saying everything in the parentheses gets this. So then it would become negative 3 times negative 3, right? For this one. And then this would be x times x. And then we would have y times y. Yep, if I don't have this, then I just have this here, then it would be negative 3 times x times y times y. Okay? Because if there's nothing up here, what's it understood to be? Understood to be a 1. Okay? It's understood to be a 1. But wherever something is understood to be a 1, we never put it. Right? If I say that x, uh, let me do that. No, I can't think of an example, so let me not do that and confuse you. Emma, my answer? Well, if it was asking me to simplify this, and I just had it was a monomial like this is, I would just break it down. I would just break it down to like this here, and I'd be done. But where the problem arises would be, let me just turn to one and show you. I'm really bad about trying to think of one and then causes all kinds of confusion. Um, let's look at the one yesterday. This was the problem we did yesterday. It was 2ab, a squared b, 3b cubed. Okay, and it's looking for an answer here. So there's a lot of ways we can do this, guys. There's a lot of ways we can go about this. Let me show you the shorthand way to do this. Okay, if you can do multiplication and addition, this is the way you can do this. Okay, we always take the constants. Constants are what? They're the numbers. They're the numbers, right? Yeah, they're the numbers. And what constants do I have here? I have a minus 2 and I have a 3 and I have a 1. I have a 1. Technically there's a 1 here, but we don't really show it, right? So here's what we do. We multiply the constants. What's minus 2 times 3? Negative 6. Okay? Now, with my variables, I just add up how many variables I have. How many a's do I have here? One here. 1. How many here? How many does that give me? A to the third then. How many b's do I have here? 1, 2, 2 and 3 is 5, right? Yeah, and 2 a's plus 1 a is 3 a's. 1b plus 1b is 2 b's plus 3b is 5 b's. You see how I did that? That's all it is. Yeah, Amanda? Okay. The easiest thing I can tell you to do is, and I'll go back up to this one here. Maybe I won't. There we go. The easiest way to do this is to take the constants and multiply them. And, we got this -2. We have a 1 here. So -2, is still going to be -2. -2 times 3 is -6. So, I put my -6 right here. And then now I'm just counting my inventory. How many A's do I have and how many B's do I have? There's an A. There's 2 more A's. So that gives me 3 A's. So I'm going to put it down here. I have 3 A's. Then I'm counting my B's. There's 1 B. There's 2 B. I have 3 B's. So I have a total of 5 B's. And that's my answers. -6A3, B5. Does that make sense? Okay, somebody else had their hand up. Liz? Okay. So if I had 2x to the third, y to the fourth, b to the second, and that was going to be times 4x to the second, y, b to the first, what would my answer be? The first thing I want to do is what? Julia, what's the first thing I want to do if I'm trying to figure out this answer? Julia W. I'm doing this problem over here. This is my problem. I got to join my constants. I'm multiplying, right? I'm multiplying my constants. And 2 times 4 is what? 2 times 4. This constant and this constant is 8. But my variables, I don't multiply 3 times 2. Now I'm adding my variables. Okay, we're adding the variables. So I have 3 x's. I know I'm going to have an x, a y, and some b's, right? I'm going to have some x's, some y's, and some b's. So I want to count. How many x's do I have? There's 3, and there's 2, so I have a total of 5 x's. How many y's do I have? There's 4, there's 1, I have 5 y's. How many b's do I have? There's 2, and there's 1, so I have 3. I multiply the numbers, and I count up the exponents and the variables. I add them up. Multiply the constants, add up the variables. Okay? Catherine? You want the number in front. All right, so we're going to move on to lesson. So guys, that part of the lesson is, once again, it's on here for you. So if you need it, you can look at that lesson again tonight. Let me erase the mess I just made here. Okay, and now we're going to start with lesson 88. Now, lesson 88, it's a lesson that I exposed you to a little earlier in the year, and you guys kind of fought me on a little bit. It has to do with unit analysis and unit multipliers. Okay? I know, right? Listen, it's not that bad, but what I want you to do is pay attention. We got 20 minutes to try to explain this to you. Okay? What you need to understand is that I can say that 60 seconds is the same thing as 1 minute. Okay? Would you agree with that? I can also say that 1 minute is equal to 60 seconds. It's the same thing. Okay? I can also say that there's a relationship between minutes and hours that I'm familiar with. I know that there are 60 minutes in 1 hour. Okay? I know that there are 7 days in 1 week. These are all things I know, and they're unit multipliers. I can use these things to go from one measurement of time to another. Well, we can do this with weight, we can do this with distance, we can do this with all kinds of things, not just time. So if you're ever posed with the question of, how many minutes are in a week, we can use these unit multipliers to figure that out. We can say how many minutes are in a week. Question mark minutes are in a week. Using unit multipliers, we can figure that out. We can start with what we know. This is our word problem right here. How many minutes are in a week? That's our word problem. And in that word problem, what we know is we have a week. We have 1 week. Would you all agree with that? We know we have 1 week. Okay, and we're trying to get to minutes. And we're going to use some of these unit multipliers to get there. These are things that we know. So the first thing I have to do is I know I have to wind up with minutes. I have to have minutes. So I've got to get rid of the week. And the only way I can get rid of that week is if I put the week, the unit, as a denominator in the next ratio. And then now my question is, I'm trying to get to minutes. Is there a relationship that I know of in my head between weeks and minutes? Not off the top of my head, I don't know how many. I can figure out how many. I don't know how many weeks are in a minute, but I know how many days are in a week, right, Julia? But they want you to do it that way for a reason, because you're going to be full of doing this throughout your mathematical life. So you got to understand this way. Okay? So here's what we're doing, guys. What do I know? I know that 1 week has 7 days. Would you agree? Okay, so what do I get to do because of this? Now I can cancel out my weeks, right? The weeks cancel out. Just like if I was doing a math problem and I had 3 over 2 times 1 over 3. Right? I really can't do that. That wouldn't work, would it? No. Oh, I could cross reduce. Yeah, I can cross reduce that. Sure could. This can change to a 1 and a 1, right? I cross reduce. I can cross reduce that. But so my point is, guys, if we have something in the numerator and we have the identical thing in the denominator, they cancel each other out. So the weeks cancel out. And now I have to find a relationship. I have days I have to get rid of, right? Because I'm trying to get to minutes. Do I have a relationship between days and minutes? Not really. I mean, you could, right? But I know that 1 day has 24 hours, right? Then I can continue down here. I get rid of my days. Okay, now I have hours. I'm just going to bring this down. I'm just going to bring this back down so you can see 24 hours, 1 day, and we cancel out the day. Now I can say that there's a relationship between hours and minutes, right? I could say 1 hour has 60 minutes. And I got rid of my hours. It's left me with minutes, right? Which is what I wanted to go to, correct? I was trying to get to minutes. So once I do that, I'm done. Now I just multiply my numerators and I divide by my denominator. I have 1 times 7 times 2 times 24 times 60. Okay? If I multiply all that out, I get a large number. In my denominator, I don't have anything but 1. So whatever I get for my numerator is going to be my final answer, which is what, London? 10,000 what? 10,080 minutes are in 1 week. Okay? Okay? Anna? Okay. Listen, you need to use unit multipliers because on the test, if it tells you to convert something using a unit multiplier, I am checking your answer for using unit multipliers. You cannot do it your way. You've got to use unit multipliers or it will be wrong. On the test. Huh? Yes, I will. Yes, I absolutely will. This is important. You have to know how to do it this way. Okay, well, hopefully this first problem is going to... Well, listen, that actually is one of the problems. It wants us... Now, here it's telling us to use the sample problem in the book, it says, use 2 unit multipliers to convert 5 hours to seconds. So what I'm going to do is I'm going to start with what I know, my 5 hours, and I know that it wants me to go to seconds. So I'm going to put seconds over here. That's where it wants me to go. That's where I'm building a bridge, guys. I'm trying to get from this side over here to seconds. So I have to build a bridge, and I have to use unit multipliers, and it wants me to use 2 unit multipliers. So I ask myself the question, do I know anything? First of all, I have to put hours down here because I have to cancel these out, right? So my hours cancel out, but before I put any numbers in here, I want to know, do I have a relationship between hours and minutes, or hours and weeks, or hours and days? I have a relationship between hours and days, right? Don't I? I can say that 24 hours is in one day. Okay, so my hours cancel out. Going from minutes. Oh wait, we're going from hours? Oh yeah, we're going to minutes. So we can't do it this way. We're going to use too many multipliers. My bad. Hold on. Let me start this over because I was going an extra step. Huh? Well, the book is asking you to use two. So we're gonna bypass that, and we're just gonna put. They want us to use two, so we're going to seconds. So we're gonna have to say 1 hour has 60 minutes. Okay, does that make sense? Forget about this. I'm going the longer version. They want you to use two unit multipliers, so they want you to skip one. I was going to use them all. Okay, so our hours cancel out, and now I'm left with minutes, but I need seconds. So I have to put minutes down here, right, so I can cancel it out? And what's my relationship? Is there a relationship between minutes and seconds? I know that 1 minute has 60 seconds. Okay, so my minutes have canceled out. I'm left with seconds right here, which is what I wanted. So now I just take my math. 5 times 60 times 60 divided by 1 times 1, which is 1. So what's 5 times 60 times 60? It's 18,000. So it's 18,000 seconds are in 5 hours. Okay? Yeah. You get that? Yeah. 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 Okay, guys, you understand that? Are we okay with that? Yeah. Huh? 60 times 60 is going to be 36, right? Look at 60 times 60 is 0 and 0, placeholder, 0 and 36. 3,600 times 60, or times 5. So now we have 3,600 times 5. 5 times 0, 0, 0, 0, it's 30, carry the 3. 15 times 3, or is 5 is 15 plus 3 is 18,000. Okay? We'll do another one. Okay. Diego wants to carpet a 16-foot by 19-foot room that has an area of 144 feet squared. Carpet is sold by the square yard. How many square yards of carpet does Diego need? This is a little, they could start with an easier one. This is not an easy problem. I'm going to tell you that right now. Yeah. Well, they're doing it in the third one too. I remember this from last year. I, yeah, I don't really know why they do this. This is really this is a little bit confusing, I think, for the. Well, no, we're gonna get through this because you're gonna have to. Okay. But what we know is, for example, too, guys, what we know is we have 144 square feet or feet squared. Okay. And we're trying to find out how many square yards of carpet we need. So we have to go from feet to yards. We have to go from feet to yards. Okay, so if we're going to do feet squared, we're going to rewrite the problem into 144 feet times feet, right? That's going to give us feet squared. Feet times feet is going to give us feet squared. Just like before when we added x and x. How many x's did we have? We had x squared, right? We had x squared. So if we have x to the second, if we have feet and feet, we're going to have feet to the second. Instead of having a variable like x or y, now we have feet. But it's the same thing. We add them together. So we're going to because it's in squared stuff, we want to break it down, and we want to have each one represented by itself. So we have 144 feet times feet gives us 144 feet squared. Now, we're trying to get rid of the feet. We're trying to go to yards, right? So we ask ourselves the question, do we know of any relationship between yards and feet? Hang on. This has to be feet down here, my bad. Right. The relationship is, we know that there are 3 feet in 1 yard. Okay, but we got rid of this 1 foot, see? But we didn't get rid of the other one, so we have to do it again. So we have to go 3 feet to 1 yard. And that foot gets rid of that foot. You understand? All right. And then now we just do our multiplication because how many we needed yards, square yards, right? How many square yards of carpet? So we have 2 yards. That means they're squared. Now we simply multiply our numerator and divide by our denominator. We have 144 times 1 times 1 is going to equal what? 144 yards squared, right? Divided by what? 9. Divided by 9. So when we divide 9 into 144 yards squared, we get 16 yards squared. Okay? That's not so bad. The only thing you have to know about this problem is when you have that, look at the board for a minute. Let me change the color so I can see. When you have this feet squared thing in the beginning of the problem, just break it down like this here. So you have a feet and a feet. That gives you squared feet. And when you have to convert that to yards, you just do it twice. You have 3 feet is equal to 1 yard. That gets rid of the 1 foot. But we still have 1 more foot to get rid of. So we have to have 3 feet to a yard to get rid of that 1 foot. And then we're left with yard, which is yards squared. And we just do our multiplication and our division. Okay, not so bad, right? We'll do another one. London? Yeah. Okay. A masonry contractor needs to pour a concrete foundation for a block wall. The foundation is 1 foot deep, 1 foot wide, and 100 feet long. A cement truck, so we're talking about 100 foot deep, 100 foot wide, and 100 foot long. How many feet is that? Is that squared feet or cubed feet? Cube. We got 3 feet. We got feet mentioned 3 times, right? So make sure you pick up on that. Anyway, a cement truck will deliver the concrete. How many cubic yards? It's telling you it's 3, right? Not how many square yards. How many cubic yards of concrete should the contractor order? Well, we know that he's starting with a foundation that's 1 foot deep, 1 foot wide, and 100 feet long. So that's going to be 100 feet times feet times feet, which is going to be 100 feet cubed. Did you all understand that? Okay, that's important. And we're trying to find out how many yards. I'm going to put yards over here because we want cubic yards. We want yards cubed. So how do I break this 100 feet cubed down? I'm going to go with the 100. I'm going to put foot times foot times foot to separate the foot cubed to this way so I can work with it. Does that make sense? Okay. And now here again, I have to get to yards. It just so happens that I know of a relationship between feet and yards, right? We already said that 3 feet equals 1 yard. So if I do that, I get rid of this foot, gets rid of that foot over there, right? But I still have to do it again. I need to have 1 yard equals 3 feet. So I can do what? So this foot can cancel out this foot. And then I have to do it again. 1 yard equals 3 feet. Why? So this foot can cancel out this foot. Now what am I left with? I'm left with yards cubed because I have 1 yard, I have another yard, and another yard. So that's my yards cubed. I multiply 100 times 1 times 1 times 1, and I get 100. Okay, and it's going to be yards cubed because that's my unit of measure. And 3 times 3 times 3 is what? 27. So if I divide 27 into 100 yards cubed, what do you think I get? It's going to be 3.7 yards cubed. They don't want to round it. Does that make sense? Oh, they did round it, didn't they? Concrete. Huh? To what? Oh, in a minute. Okay, guys, what I want you to do is I want you to close your books. I'm going to pause this. We're going to do practice set now. I'm pausing this, shutting this off. Okay, so we have 5 yards. And we're trying to go to inches, so I can't go from yards to inches. I have to go from yards to something else. They want me to use at least 2, but I know that 1 yard has 3 feet. Okay, so my yards cancel out, and then I can say that 1 foot has 12 inches. Okay, I got rid of my foot. I got my inches that I want, so now I just multiply 5 times 3 times 12. So the best way to do this is probably 12 times 5, which is what? And then times 3. It's 180. What's my units? Inches. Not so bad, right? That was